So now in this video, we're going to talk about the current state of general purpose large language models in SysML V1 and V2. Currently, this is as let's say last winter, I was starting to think about, well, okay, right now we're still kind of working on this problem of trying to get to the domain level of SysML V2 models. And I've been watching then large language models progress. I've done some previous videos around them. I've been working with them using APIs to kind of interact with them, with Python for Capella and such. And I started thinking, well, what could we do with large language models? One of the things I had noticed is that large language models are very good at translating and creating data. So it began an investigation into what I could do. And one of the things I really was looking to was what I could do specifically around SysML V2, because maybe the large language model could help me extract information to basically give me this equivalent of a domain API that I'm looking for. And interestingly enough, I kept testing large language domain models. And one of the things that is, and also I came across this book. It's a great book. I recommend getting it, reading it. Most of the things in this book you can do even with Arcadia and Capella models. It actually, in this case, is using SysML V1. But again, SysML V1 is well-defined language, and also Arcadia is a well-defined language. So many of the things that you can do here around processing a SysML V1 diagram and generating content out of it, you can do exactly with Capella. In this case, I actually did do an evaluation both with SysML V1 and SysML V2. And I found that, general purpose large language models, they can write and read code very well. They can read SysML V1 diagrams. And then therefore I wanted to see what more it could be done with SysML V2. One of the things I used for this is I actually have a distiller model. The distiller model is a common model used in training. I don't note here the original textbook that it came from, but here's a representation of that distiller model in Rhapsody. There's ones available, of course, in other versions, other products that you might find out there. Now, in this case here, I actually built a prompt, and I provided a PDF copy of the diagram using SysML V1 and using the notation, and I created a prompt that basically says, perform the analysis on the PDF file and basically using SysML V1 notation. And now this is critical. You got to tell it that the diagram has SysML V1 notation, and then describe in details the contents of this IBD. And when you do that, the results are very good because it can do a very good job of processing the graphical description. However, the negative of that is it's not really working on the model. It's working only on the graphics in the model. So what happens when you have just a subset of the information or a view of content, just like we can create with Capella? Could something that work like that work with Capella? And the answer, yes, it could, but it's not going to give you the full model content. Likewise, with SysML, now SysML V2 is very different. With SysML V2, I actually created an Arcadia Capella model. And Siemens actually has, because of the work that we did on mapping to the Arcadia to SysML V2, we actually do have a SysML V2 converter for the Arcadia model. Now, this is not a released product yet. It is something that is available for customers to try for evaluation upon request. I will provide at the end of this lesson a contact number if you're interested in pursuing that. You also can reach out to me. But this is a very powerful tool that actually takes the entire Arcadia model, all the different phases, and essentially creates a SysML V2 representation of that. And it does that against an Arcadia library. The product is designed to be bidirectional. It is essentially an add-on to SMW, our System Modeling Workbench tool, which is based on Capella, but it's also technically an add-on also to Capella. Now, what this does is it actually takes the file and creates multiple packages for each of the phases. In this particular example, I could not run the entire model, and this is not a big model to this store. I could not run the entire thing through OpenAI. The main reason why I couldn't do the whole thing was token limits. The model was quite large, and so I had to carve the model down by essentially cutting and pasting down to the logical architecture only. And then I was able to actually provide to it a query, and there's some minor inconsistencies here between the names of the files and the file names that you're seeing down here. But I was able to load up the Arcadia library file. I was able to load up the trimmed down logical architecture version of the distiller file, and I was able to then run those files with a query using the terminology of Arcadia. Now, this is a big deal because it means that the large language model is understanding the fact that this is a library, and I actually do specify in here that the arcadia.txt file is a library that defines the term of the Arcadia domain. And so it means the large language model is comprehending, and in this particular case, I use 4.0, and this was done, and interestingly enough, this was done multiple times. It was done in 2024, the end of 2024, and again in the May timeframe of 2025. The results changed dramatically, and the results were very good in the last time I did this in 2025. And the results were to give me back a report that basically did understand the model. It gave me back the terminologies in terms of components and functions. And this is a big deal. This shows that large language models do have the potential then to be able to comprehend something like the Arcadia domain, and then this can also then be very helpful in, again, kind of getting things in the terminology of Arcadia. Now, and that's kind of was a really great finding, and it shows the potential then of SysML V2 as a way to basically to work with AI. And that's great because then I'm showing now then we can read SysML V1 diagrams, we can read and write, we can write SysML V2, that's actually shown in the book, to a limited degree without training, and we can write valid V2 with training. So that was also noted in the book. Now, one of the things still though to be as a challenge is that to read the SysML V2, the token limits does, constrain the model size. And of course token limits will grow, but lo and behold, the models will grow also. And one of the interesting thing is with, doing a conversion like we did in this case, the model is quite large for SysML V2. Anyway, and we also use that essentially the library is being used to train the V2 in the terms of the Arcadia method. So that was also something that was really exciting by this finding. Now, here, it kind of concludes this section of it. These are some contacts information here if you want to. Right now, Karen Ryan, she was the co-presenter at INCOSE last year on the SysML V2 work that we did. Would be the primary contact if you're interested in getting this information and looking at how you could get to SysML V2. But that's not your only option. And so that kind of leads into our the next presentation that I will go into about what we can do right now. And specifically what we could do with the Capella tool right now, and a combination of the Capella tool and APIs that are available. What could we do to kind of tackle this left side of the V problem? So I'm going to pause right now. Again, here are some of the contacts that you can reach out to on this presentation, and we now will go into the final part.